So far, we've explored equations that perform algebraic operations to produce one or more results. A function is a way of encapsulating an operation that takes an input and produces exactly one output.
For example, here's a function called f that takes in an input variable called x and returns x plus 2. Now, if we use this function with an x value of 3 to set the value of a variable called y, then y, of course, is set to 5. We can plot this function to show the output value for every possible input value. In this case, the function is a line in which y is always at point x plus 2. Okay, let's look at a different function. This time the function is called g, and g of x is 10 divided by x. So, g of 5 is 10 divided by 5, which is 2. What happens if we try to use the function with an x value of 0? Well, anything divided by 0 is undefined, so the function is undefined for an x value of 0. Now, we call the set of numbers for which the function is defined is domain, and in this case, the domain of function g is defined with x in the set of all real numbers such that x is not equal to 0. Now that looks a bit mathy, so sometimes you'll see it a little less formally written, like this. If we plot this function, the values of y for every possible x is shown, but note that as x gets closer to 0, the values of y never meet, because the function is not defined for an x value of 0. Alright, let's look at another function. Function h returns x squared. Well, let's look at the graph for that function. And note that when you multiply any number by itself, the result is always 0 or greater. You can't square a number and get a negative value. So the possible outputs for function h, which we call its range, is defined as being the set of all real numbers such that h of x is greater than or equal to 0.